All right, this is page 10. I'm just going to do it on paper and hope that this will help you follow along. Page 10, number 3 says the terminal side of angle ROP in standard form intersects the unit circle. So that means you need to start with a unit circle. So let me draw one. It's got to be neat, and unit circles get labeled. So here's X, here's Y, here's negative X, here's negative Y. Now, if this is a unit circle, that means all your radii are 1. However, this is number 3 is hitting a point at P at 3/5 and at 4/5. So here's your angle that they said. This is angle ROP. So here's R, here's O, here's P. So I'm just going to call it theta or P, whatever you want to call it. So they want the sine, the cosine, and the tangent. All right, well, both X and Y are positive, quadrant 1. And your cosine is the X coordinate. And if the cosine is the X coordinate and the X coordinate is 3/5, therefore cosine of theta is 3/5, and then secant is the reciprocal, 5/3. Done. That's it. Sine, according to your notes from the unit circle, day 1, the sine of theta is equal to the Y coordinate. So now you come over here and you have sine of theta is your 4/5. That's it. There's no great mystery to this. And then you flip this over and you have a cosecant. And that would be 5/4. Now, the one thing I said is that sine and cosine are proper fractions, and then secant and cosecant are improper, and that's always going to happen. Tangent is sine divided by cosine. So if you add 4/5 divided by 3/5 and you used your calculator, or you went back to when we did fractions, the common denominators will cancel, and you have 4/3. Your cotangent now is going to flip over and it's going to be 3/4. Now, the other thing you could do, so I showed you 2 things. This is the first thing. The other thing you can do is go back to this picture. Draw your full triangle. And if your cosine is 3/5, and 3 means adjacent over hypotenuse, you can pull that out over here and you can write, if here's where the theta is, adjacent is your 3 and your hypotenuse is 5. If this is your sine, opposite over hypotenuse, here is your opposite, 4/5. And then you could have gotten your tangent straight from opposite over adjacent. 2 ways you could go. But guys, this is even easier than using the Pythagorean theorem. If I jump to, say, number 9 now. Number 9, again, you have to have your unit circle. It has to be there. It has to be labeled. And it is the point. Oh, wait, I don't want to do 9. 9 has all positives. Let's take a look at number 7. 7 is negative 5/13, negative 12/13. Well, if I'm negative 5/13, so there's my P. Negative 5/13 and negative 12/13, I am in quadrant 3 because that is where X is negative and Y is negative. There's my cosine. There's my sine. So now if I write myself my little list, my cosine theta, negative 5 over 13. My secant then is negative 13 over 5. My sine, negative 12 over 13. My cosecant, negative 13 over 5. Now my tangent, again, is sine over cosine. Double negative makes it positive. That is why I said quadrant 3 is tangent's quadrant, because a double negative makes a positive. Denominators cancel from complex fractions, and I have positive 12 over 5. Cotangent is positive 5 over 12. Again, I can pull the triangle. I can make this into a triangle if I wanted to, and I can pull this triangle out. This is where theta would be, because it's always at the origin. And so if cosine is adjacent over hypotenuse and sine is opposite over hypotenuse, on a triangle they're considered positive, because again, the negative is the direction. So here you go. Let me know if this little 7-minute video was helpful, and good luck on the rest of the problems.